Welcome all for this video class. So in this video we are going to learn about 8085 pin diagram. So 8085 is a microprocessor, so which has 40 pins. So we are going to learn about the pin diagram and its details in this class. So this is the pin configuration. So it has pin diagram 40 pins. So one side 20 pin, another side another 20 pin. So this IC is named as a DIP IC, dual inline package. So the next diagram is a signal diagram of pin configuration. So this is the details about the pin diagram. So x1 x2 is a crystal input, so which can generate the clock pulse internally. So we can connect externally the crystal device in the x1 and x2, depends upon the crystal input. So it decides the clock range or clock range of the clock frequency of the microprocessor. So we requires external input from the clock input from the crystal device. So the next pin is pin number 3 and pin number 36. Pin number 36 is used for reset in. So bar means it is an active low signal. So the third pin is an reset out pin. So it is used to reset the external peripherals and disabling other interrupts and all. So if here goes to output high, it is becomes active. So it is an active high signal. So when we are going with the reset in means it is an active low signal. So reset out means it is an active high signal. So the next fourth pin and fifth pin. So it is used for the serial input data and the serial output data. So it is an 1 bit pin. So it is used to store in the MSB bit of the accumulator, store the bits of the MSB bit of the accumulator. So here it is using a read interrupt mask instructions is used to transfer the bits from serial input. So similarly in the serial output data also. So here from the MSB bit 8th bit it will be transferring to the output. So here the instruction used is set interrupt mask instruction is used for the transferring bits from the microprocessor to external peripherals. So the next from the 6th pin to 10th pin, it is an interrupt pins present in the 8085 microprocessor. So pin number 6 is a trap input. So it is a non-maskable interrupt. So it will not able to hide this interrupt in the pin number 6. So it has the highest priority and both it will be edge triggered and level triggered. Next trap is usually used for the power failure and emergency shutdown. The next pin is RST 7.5. So it is a maskable interrupt. So it has second highest priority. Next it can hide by using the mask interrupt. Next it is a positive edge triggered pin. The next this is a maskable interrupt. It has the third highest priority and it is a level triggered only. The RST 7.6.5 can be enabled by the enable instruction EI instruction and disabled by the DI instructions. The next it is the fourth highest priority. It is also a maskable, so it is also a level triggered. So this pin is very similar with the 6.5 pin, but the priority is differ. The next INTR, so it is the lowest priority among the 5 interrupts. So it is also a maskable, it is also a level triggered. So it is used for the general purpose interrupt making it will be used. The next this is an interrupt acknowledgement pin. So it is an active low signal. When the active is low, so the interrupt is acknowledged to the external devices. The next we are going to see about the address pins and data pins. So address bus, what is address bus means? group of wires sending address to memory means that wires is named as an address bus. So in this 8085 has 16-bit 16-bit address, as well as data bus means transferring data between a microprocessor and a to memory, or memory to microprocessor, or to memory to microprocessor to IO devices. So that is named as a data bus. So in this 8085 microprocessor has 8-bit data. So that's why this processor is called as 8-bit processor. So next, so regarding to the address and data bus, we have AD7 to AD0. This pin is used for dual purpose address as well as data. So pin number 0 is in 19th pin, and up to 12th pin, 12 to 19, the address and data is pin is present. So here AL is used for the address latch enabled. The next we are going to see about the address pins. This is a higher order address. This higher order address, so it can send only the memory, communicate with the memory only. So it has high impedance state during the hold and reset mode. The next we are going to see about ALE. The ALE is used as a control input, address latch enable. So it is used to latch. It is used to enable the address or data by using the AD pins. If AL is 1, the bus function is address bus. AL is equal to 0, the bus function is data bus. So it is used to enable or select a address or data pins in the AD0 to AD7. The next control pin is status inputs, S0 and S1. This tells the current operations of the microprocessor. 00 means it is halt, 01 means write, 10 means read, 11 means opcode fetch. So the next IO/M bar, this is another control input. If IO means input output, M means memory. So M is an active low signal, IO means an active high signal. If IO/M bar is equal to 1, then the operation is IO function. If IO/M bar is equal to 0, then the memory operations will be performed. The next operation being performed indicated by the S0, S1. Okay. So this is a combination. So it is used in the timing diagram also. IO/M bar S0, S1. So this is an operation 0, 1, 1 for opcode fetch, 0, 1, 0 for memory read, 0, 0, 1 for memory write, 1, 1, 0 means IO read, 1, 0, 1 means IO write, acknowledgement 1, 1, 1 means acknowledgement, halt means there is a no, 0, 0. No in anything X means IO/M bar means anything, 0, 0 means it is in halt state. Next, read pin. So it is the 32nd pin. Read pin stands for read. It is an active low signal. So it has some control of read operation either from memory or from input devices. The next, write. So here WR stands for write. So it is also a active low signal. Active low signal means the signal itself, the bar is present. So if you are giving input 0, it will be active. So, so the pin number is 31st. So it is also used to interface with memory and output devices. The next, ready pin. So synchronize the slower device with the fastest microprocessor. So if we are interfacing any other slow devices with the 8085. So this signal is used to synchronize the both interfacing devices. Next, hold and hold acknowledgement 38 and 39. So it is used for the direct memory address transfer. So from this transfer itself, for the data transfer between memory to memory happens without support of the microprocessor 8085. The next, so it is a hold acknowledgement. Hold acknowledgement is used for the DMA also. So it will be acknowledged for the data transfer. Next, VCC and ground. So 20th pin is a ground pin. So it is most important for this pin. So it is powering to the ICCs. 40th pin is VCC. VCC means it will be a 5 volt signal. Okay, thank you.